Today we are going to discuss about Newton's laws of motion. For this, if you see here, there are three visuals. One is Newton's, which describes Newton's first law of motion. The second one, which describes the Newton's second law of motion, and the third one, which describes the Newton's third law of motion. Let us see in detail what are the Newton's laws of motion and how they are useful in our daily life. So moving on to the next slide. So it's just I have given description about Sir Isaac Newton, who has formulated all the three laws of motion. So he was born in the year 1642 and died in the year 1727. So he worked out the three laws of motion, which governs the movement of all objects at all times and in all circumstances. So these three laws of motion are helpful for how the objects are moving from one place to another place in all the circumstances. So these three laws were published in his book called Philosophiae Naturalis Principia Mathematica, which deals with the mathematical principles of natural philosophy in the year 1687. Next, moving on to the next slide. See here the famous quotation which is given by Sir Isaac Newton is that if I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. So next, inspiring from this quotation, we will move on to the next topic, which deals with the Newton's first law. As I have already told, Newton has formulated three laws. In that, the first law is called as Newton's first law. So this first law is definition. If we go on to the definition, so the definition goes like this: an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So here it means that any object or any body which is at rest will be at rest only, or continue to stay in rest only, or a body which is moving will be in that position only until and unless some other external force is applied on it to make it to stop or to make it to move. So this is nothing but, so that means here comes the term force. That means force is required for any object to stop or to move. So to describe this, I have shown you a figure. So where a car is moving, so before it reaches to this wall, the man has to apply some force that is called as brake, so that the car stops without hitting the wall. So that means this car which is moving, if we want to make it to stop, some force should be applied so that which is moving, it should stop. So what does this mean? So basically, I have already told that an object will keep doing what it was doing earlier unless acted on by an unbalanced force. That means if an object, if it is moving, will be in moving position. If an object which is at rest, will be at rest only until and unless some force or unbalanced force acts on it. Okay. Next, if the object was sitting still, that means it will remain stationary only. Or if it was moving at a constant velocity, then it will keep on moving. So to stop or to make it to move, it takes force to change the motion of an object. Any object, if you see, or if you want to throw a ball, so some force is applied so that the ball moves from one place to other place. So next we'll move on to the next slide. So what is meant by unbalanced force? So I have already told that some unbalanced force is required for any body to move or to stop. So let us suppose I have taken one book. So that book is on the table. So that here, if you see, there are two forces acting simultaneously on the same body. That is, the table is pushing upward on the book. As the book is on the table, so that the table is applying force on the book so that it is moving in the upward direction, whereas the gravity is pulling the book downwards. So these are the two forces that are acting on the same body simultaneously. So the forces on the book are balanced. So gravity is pulling down, table is pushing up. So both the forces are balanced. Hence the book is not moving, or it is not moving. So it doesn't have any movement. So for this book to move, at least whether the force applied by the table should be more, or the force applied by the gravity should be more. Hence these two forces are balanced, the book is not moving. So if you see the definition, if the forces on an object are equal and opposite, if you observe here, so both forces are equal and they are in opposite direction. One is pushing up, one is pulling down. So that means the two forces are equal but in opposite direction, hence they are said to be balanced. So the force applied on the body is said to be balanced. If they are not equal and opposite, then the forces are unbalanced and the motion of the object changes. So I have already earlier I have told that if any of the forces which is pulling up or pushing down is more than the other one, then the body would have, or the book would have moved from its position. So hence we require some unbalanced force so that the body which is at rest is brought into motion, or the body which is in motion is brought into rest. Next, if you go observe some examples from real life. See, here I have shown a soccer ball. A soccer ball is sitting at rest. So if we want to move this ball, I have already taken the example of ball. So it takes an unbalanced force of a kick to change its motion. Until and unless some person kicks this ball or some force is applied on the ball will not move from its rest position. In the same way, I have taken one more example of tug of war. So if you see, we all have played in our childhood days this tug of war. So we know that two teams are playing tug of war. So they are both exerting equal force on the rope in opposite direction. So because the forces are balanced, neither of these people move to the other side. So this balanced force results in no change of motion. If one of the team applies more force than the other team, then the other team will surely fall or will surely come to the position of the first team. So hence, when there are equal forces are applied on the same object in the opposite direction, there won't be any change in the position of the body. See, to describe in the descriptive manner, I have showed the first law. See, best example is that if we take a glass and if you put a paper on that or a cardboard, then if you put a coin over it and if you flip with our finger, then what happens? You observe at your home doing this experiment. So what happens? The paper as well as the coin will fall onto the ground, or the paper only moves, or the coin falls into the glass. So the second one happens, that is the paper will fall onto the ground, whereas the coin which is on the paper will directly fall into the glass. So the coin would be in rest unless acted upon by an unbalanced force. So again, one more example. Once airborne, unless acted on by an unbalanced force, it would never stop. Here we have shown the example of polo. So the ball is at rest position until hit by a polo stick. The ball will not move to the other position. So let us think for a while. Why was it so difficult to stop the Titanic from colliding with the iceberg? Why couldn't we stop, or why it was difficult to stop the Titanic from colliding with the iceberg? So if we think this, so there comes one more point here which is an important thing, that is called as inertia. Inertia is nothing but the property of the body, so which makes the body to move or which makes the body to be at rest. So that is called as inertia. Inertia is the concept that has been derived from Newton's first law. So as if I have already taken the example of Titanic, why was it very hard for making us to stop, for not hitting or not colliding with the iceberg? Because the mass of the Titanic was very large. So the Titanic weight was very high. So because of this, inertia is directly proportional to mass. If mass is high, inertia will be more. Inertia is the inherent property of a body to resist the change in its position. So if you see here, the mass of the Titanic is very large. Hence what happens? Inertia will also be more. If inertia is more, that means it changes or it opposes the change in its position. That means it will oppose the movement of the body to move to the other side. So for that reason, what happened? The Titanic couldn't change its direction immediately because of its extremely high inertia. So that forces it to continue in a straight line, thereby colliding with the iceberg. So as it was moving in the straight line towards the iceberg, because of the high mass, because it possessed high inertia, it couldn't change its direction to the other side. Hence, we couldn't stop colliding with the iceberg. And even if we see example of children sitting on a seesaw. So what happens here? Both two children are sitting on the one side and the other fat person is sitting on the other side. Because the weight is more, so inertia will be more on the fat man's side. Hence the body will tend to be in that position only because of the weight of that person. So now we will move on to Newton's second law. Newton's second law describes the relation between the force and the acceleration. So the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So we know that means from this equation we can show that F is equal to ma. That is, F is nothing but force, m is called mass, a is acceleration. If you see the relation between force and acceleration, F is directly proportional to a. That means if acceleration is more, the force applied should be more, or if the force applied is less, that means the acceleration of the body will also be less. So what does this mean? What does F is equal to ma mean? That means force is directly proportional to mass and acceleration. Imagine a ball of certain mass moving at a certain acceleration. This ball has a certain force. So now imagine we make the ball twice as big. That means the mass has increased twice. So but keep the acceleration constant. That means acceleration is a only, but mass has become 2m. Hence what will be the force applied on the ball will be there? It will be the twice the force of the ball which is applied on the first ball. First ball is F is equal to ma. Second ball is equal to F is equal to 2m into a. Hence the force applied is also becomes double. Now imagine the original ball moving at twice the original acceleration. Let us suppose in the third instance, let us increase the acceleration, that is from a to 2a. Then F is equal to ma says that the ball will again have twice the force because of the ball at the original acceleration. Because the acceleration has doubled, the force will also be doubled. So if mass or acceleration changes, then it will have direct effect on the force applied. So more about F is equal to ma. I have just now told that if you double the mass, you double the force. If you double the acceleration, you double the force. That means whatever changes in mass and acceleration is applied, that will be directly shows effect on the force. So what if you double the mass and the acceleration? That means we have doubled the mass and we have doubled the acceleration. Hence we know that F is equal to ma. Now m has become 2m and acceleration has become 2 into acceleration. Hence the force has increased to 4f. That means quadrupled. Doubling the mass and the acceleration has quadrupled the force applied. So now think, what if you decrease the mass by half? So if you decrease the mass by half, how much force would the object have now? So think for a while and find out the answer. Next, what does F is equal to ma say? So F is equal to ma basically means that the force of an object comes from its mass and its acceleration. As it is a product of mass and acceleration, so the force can be derived from mass and acceleration. So how we can show with the real life examples is that everybody has seen the glacier. So something very mass, so glacier is very high, having high mass. That means because of its high mass, the speed of because of high mass, the inertia will be more. Because of which its speed will be very slow. So that means it contains low acceleration. So that means though it has low acceleration, because of high mass, a glacier can still have a great force. If any of the parameter, whether mass or acceleration is more, then F will be more. Hence, even though the glacier is having little acceleration, but because of due to its high mass, it will have high force. In the same way, take one more example, that is a bullet. So bullet, if you see, the mass of the bullet is very little, but the acceleration of the bullet when it is fired from a gun is very high. because as F is equal to m into a, though its mass is small, but acceleration is very high. Because of the acceleration is high, the force applied by the small bullet is very much high, hence it contains a heavy or high force. Something very small, that means whose mass is very low, but changing speed is very quickly, that means it contains high acceleration. Like a bullet can still have a great force. Something very small, changing speed very slowly, will have a very weak force. If the mass is less and the acceleration is less, then only we will have a weak force. But whereas if any one of the parameter is high, even though the mass is small, acceleration is high, the body contains with high force, as well as if the mass is small and acceleration is high, the body will move with a greater force. Next, if we see the example of this person who is playing baseball, what is the function of the hand glove of this baseball player? Why a baseball player is wearing a hand glove? Think for a while. So, because we know that force is inversely proportional to time. That means F is equal to, we know that m into a. Acceleration is nothing but mass distance by speed. Distance by time. So distance by time square, which is nothing but F is inversely proportional to t square. That means if we see the relation between F and t, F is inversely proportional to t. That means if time increases, force will be reduced, or if time is less, force will be increased. So for any baseball player or cricket player, wearing gloves is necessary because the ball is coming with a very speed or very high acceleration. Because of the acceleration, it will have so much of force. It will, if it hits the hand, so what happens? The player gets bruised. In order to increase the time of reaching or time of colliding the ball with the hands, the baseball player or the cricket ball player wears gloves, and as well as he takes his back hand before catching the ball. Because before catching the ball, if he takes his hands to backside, the time interval from the ball hitting to the colliding hand will be more. If time is increased, the force applied by the ball on the hand will be less. The chances of getting wounded will be less. The hand glove increases the time of the collision, thereby reducing the force. So after learning all these concepts, we will check our understanding of what we have learnt. So first question, my question is, what acceleration will result when a 12 Newton net force is applied to a 3 kg object and also a 6 kg object? First instance 3 kg object, second instance 6 kg object. Here if you see the parameters, the known parameters are, he has given the force, that is F is equal to 12 newtons, and he has given the mass is equal to 3 kg. So we know that we have to directly apply the formula F is equal to ma. F he has given, m he has given, he is asking us to find out acceleration. So F is equal to ma, a is equal to F by m. So straight away substitute the values of F and m, that is 12 by 3. So the answer we will get it as 4. In the same way, it is the acceleration, hence it should have the units for meters per second square, hence 4 meters per second square. In the same way, in the second instance 6 kg he has given, so directly substitute 12 by 6, that is 2. So we get 2 meters per second square. So in the same way we have to formulate all these questions. So if the answers will be in this way. So I have already told, we got the acceleration in the first instance 4 meter per second square, as well as for the second question he has given the force and acceleration, and he has asked us to find out the mass. We know that F is equal to m by a, m is equal to F by a, so hence 16 by 5 will give rise to 3.2. So hence mass has a unit of kg, so it should be expressed in terms of kg, so we got it as 3.2 kg. In the third question he has given the force and he has given the acceleration. So he has given the mass, he has given the acceleration, and it is asking us to find out the force. F is equal to ma, m he has given as 66 kg, a he has given as 1 meter per second square. So F is equal to ma gives rise to 66 into 1, that is 66. Force is, for the units, SI units for force is newtons, hence we express F in terms of newtons. So the value we get it as 66 newtons for the third question. So now we will move on to Newton's third law. According to Newton's third law, this is very simple to understand. That is, for every action there is an equal and opposite reaction. Best example for this is movement of a rocket. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair and the chair exerts an upward force. We all will be sitting on a chair or on a bed. What happens? The body is applying force on our body in the upward direction, whereas the body is pulled by the gravity in the downward direction. As both the forces are balanced, because of which there is no change in our movement. That means a person sitting on the bed will be in sitting position only. He will not fly because because both forces A and B are equal and opposite, hence which are called as balanced forces. When there is a balanced force, the body will not move from its initial position. So the same is expressed in the third law. So example, there are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called as action and reaction forces. The force which is applied by the chair on our body is action. The force applied by our body on the chair is called as reaction force. So third law, for example, let us see a bird is flying. So what happens? Flying gracefully through the air, birds depend on Newton's third law of motion. As the birds push down on the air with their wings, the air pushes their wings up and gives them lift. Everybody might have observed, while flying, the birds will swift their wings, because of which what happens? The air is thrown down because by the help of wings. In the same way, the air is exerting same force on the body in the upward direction, so that the bird can move upwards in the air. So the another example for third law is the reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine producing hot gases. The hot gases push against the inside tube of the rocket and escape out of the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. As the gases we might have observed a rocket flying. So the gases are coming downwards. In the same way, what happens? The hot gases are coming downwards, and these hot gases are making the rocket, putting a force, equal force on the rocket to move upwards. Hence the rocket is moving upward direction. So now we will see the working of how does a rocket move, or how does a rocket work. See here, weight of the rocket is this. So the gas is moving towards downward position. In the same way, the same amount of thrust is applied on the rocket, which is called as reaction force, that is making the rocket to move up in the upward direction. So rocket is pushing gases, the first condition. Second condition, gases pushing back on rocket. So as the gases are coming with high force, the same force in the opposite direction is applied by the gases on the rocket, so that the rocket is moving in the opposite direction of the gases. So how does a jet plane work? So if you see here, some air from fan provides thrust just like a propeller. So that there is a turbine here. So gases are being pushed out of the back of the jet propeller, because of which air gets compressed and then ignited, because of which the jet plane moves in the opposite direction of the gases. Let us rewind what have we learnt in this today's topic. So the first one is we have learnt about Newton's first law, that is objects in motion tend to stay in motion and objects at rest tend to stay at rest unless acted upon by an unbalanced force. In the same way, Newton's second law, that is force equals mass time acceleration, that is F is equal to ma. And also Newton's third law, that is for every action there is an equal and opposite reaction. With this we complete today's session. Thank you. My name is S. Vidyarani. I am working as Assistant Professor of Physics at MVS Government Degree College, Autonomous, Mehbubnagar. Thank you one and all.